Today's notes will be about nutrients and transport in plants. You should be on the very back page of your plant booklet. In our third unit this year, we learned that plants take in carbon dioxide and water to produce oxygen and glucose with the use of light energy. There are a few key things then that plants need in order to be able to grow. And plants are going to need carbon dioxide and water in order to make that glucose. On your note sheet, I want you to draw a simple leaf. And I want you to just simply illustrate that the plant is going to be taking in carbon dioxide from that leaf and giving off oxygen from that leaf. Sorry that my arrows are terrible. When a plant takes in carbon dioxide and gives off oxygen, it happens through this structure called the stoma. And the stoma is an opening on the underside, typically the underside of a leaf. You can see here a stoma and here is a stoma. This one's closed, this one here is open. And when that is open, it's going to allow gas exchange. Now, sometimes the gas can be in the form of water vapor, right? So when water is in its gaseous state, it is a vapor, and it can go out the stoma along with the oxygen and the carbon dioxide. And what happens is plants then lose they lose water, through this opening. And that is why typically when we think about water being pulled up from the roots of the plants, we don't think that it can also be lost then in the leaves. And so plants will often go through photosynthesis at night when they can open these stoma and not risk excessive loss of water because of the sun and the heat of the day. So they will open these up at night in order to minimize water loss. Okay, so this process is called transpiration. Transpiration is the process by which plants release water vapor into the air through these stoma or stomata. The last thing we're going to look at here is the movement of glucose in the plant. The glucose is produced in the leaf where photosynthesis is taking place, and it has to be moved elsewhere. We talked about this yesterday with these two terms here, the xylem and the phloem. The xylem, remember, is pulling only water from the roots up to the rest of the plant, but the phloem is going to be where the food is flowing through. And when the food is produced, it's made in the leaves, which we've talked about. We know that photosynthesis is happening in the leaves. This is where the glucose is being produced. The thing is, all of that glucose that the plant is continually making can't simply be stored there. Just like when we consume food, it goes into our stomach. It doesn't just sit there, right? We digest it, we break it down, and then it goes to the rest of our body to help fuel us. The same is kind of true here in the plant. It's going to make that sugar, that nutrients that it needs, and then it's got to go somewhere else. It can't just all be held in the plant, in the leaf. And so translocation, this process here, is simply moving that to another location. So it says the movement of organic compounds. When you hear organic compounds, you should think of nutrients, food, the glucose. That's what we're talking about. When it moves from a source to a sink. And these are just fancy terms for the source being the source of production is the leaves. The sink is just its end destination. So if it's a carrot plant, that glucose is primarily going to be stored in the roots. If it's an apple tree, that glucose is going to be stored in the stems, in the branches, and in the fruit. Right? So it's going to be wherever the need is for that plant, which is why food is what flows through the phloem, because that's going to be what's moving that around to its final destination, wherever it needs to go. All right? So on your notes, you should have written already that the exchange of gases through the leaf is that transpiration, right? So water vapor going in and out of the leaf. And then the last thing would be, as food is moving from the leaf to somewhere else, that's the root or the fruit, that process is called translocation. And that is the end of our plant notes.